welcome back to Arctic C. Today a little bit of a different video. I got Morten here and he is our technical guy, and today you're going to tell us what?
Yeah, I have this C1-Chaser and we have a few questions about how I set it up, and so I think I'll talk a little about that today, just a little bit. So yeah, about I have this Inav flight controller, and I'm gonna talk a little about that and GPS and a little telemetry system. So yeah, I'm gonna tell you how I do this, and if you have a solutions, better ways of doing it, it'd be nice to have a little input. And if you can learn something, very good.
Yeah, and if you have some input, you can use the comment section below, and Morten will also try to follow it on YouTube and also go in there and answer from time to time. But I guess we just...
Yeah, take a quick go through about this plane.
Yeah.
Okay, so the C1-Chaser. I buy this from Banggood. It's a nice shop. They have everything you need in this hobby section. It's it's a China shop, of course, but if you use a little common sense, you can find in the price range you want. Cheap things are cheap, and more expensive are better quality. This is has proven to be a very nice wing. It's kind of sturdy. It has this carbon rod, so you push in, so it's very stable, can handle quite high speed, and it's both agile and it tracks very good, and it has a good speed potential. So it's a nice wing that everyone can fly. It's very light. You can put a very light setup or heavy faster setup, whatever you want. So about the setup, I have from this side I have this telemetry unit. It's a radio it's a 3DR radio. They're very common. You use it on APM controllers. It has quite good range, so you can control everything from if you have it linked to a computer or a telephone. You can pretty much set up the plane if you need to change something, and you can also track it in the air if you're flying long range. So that's a nice thing to have. And I made this antenna myself. Stiff antenna on top, flexible under obvious reasons. And and then to the video transmitter. It's a common 5.8 gigahertz transmitter, right hand polarized antenna. For they who don't know, it's very nice to have a circular polarization, because you get a much clearer image if you are using FPV. I fly this just as much line of sight, but it's a nice option. The transmitter is down here, range from 25 to 600 milliwatts, whatever I choose to set it up with. In 600 milliwatts I have to take it out quickly, because I mount it with hot glue and it gets hot, so it will fall out of the plane if I don't get it cooled down. GPS module, it's very nice to have. If you lose control, lose signal or anything, it will return to home, come back and either land or just circle above, so I can regain control. You can take off this, the receiver. It's a diversity receiver, 2 antennas. One is embedded in the wing, the other in the vertical stabilizer. So we have both horizontal and vertical antennas. Very nice to have, depending on your transmitter antenna. And can open up, see what's inside. Now this is a pretty powerful setup. I have a very big lithium-ion battery, about 7,000 milliamps, 4S. So it gives approximately flight time of 1 hour to 1.5 hours with just gliding speed. This is an amperage meter, so I can track the power usage on the telemetry on the radio. And the heart of the system is this. This is an Omnibus F4 Pro flight controller. It has a software called Inav, which is software which keeps track of this stabilizing of the wings. It keeps track of the height via the GPS module and a barometer. It can run waypoints. It can return to home if you have a problem. It can even land, kind of. It doesn't do landing very good, but it it comes down better than falling down. And it has, of course, a motor, ordinary 25-ish motor, 1100 kV, 8x6 prop, and a 40 amp speed controller. What's nice about this is that we showed in an earlier video, it has this auto launch feature. It means I can launch this by hand like this, and I don't have to be afraid that the prop is gonna cut, because the motor engaged about 1/10 of a second after I launch it. Then it runs up to speed. It will climb with about an angle of 20 degrees until I take control over it with the radio. That's a very nice feature, but of course it's not necessary, but it takes a little bit stress off throwing this alone. So I like this feature, I think it's very good. And it also have safety features. If you don't have a good signal on the GPS, you are not able to arm it and fly with it. Now I can see it's blinking green. Even if you are inside, now we have probably nice reception on the satellite. I don't have any on-screen display or telemetry with me, but an easy check is just to flick the arm switch and it's armed. Now it has locked on this position as a home position. If for some reason it flies away, I can flick a switch in return to home mode, turns around and come back here, inside here, and land on the table. No, it won't. Another nice feature is beeper, so I know what it's doing. I know if it's arming or not. If it doesn't beep right, it's not arming. Now I can hear, this is the arming sound. It's armed. I know it. So if it's not doing that, it's not armed, don't throw it, because it won't take off that. So now it's in level mode. I don't know if you can hear it or see it, but now the elevators are moving to keep it level.
Those are quite silent servos.
Yes. This is digital servos. They're very silent, very nice servos. So it's, but you can maybe see it that they are.
Yeah, I can see it.
So if you plug this to a computer and Inav's programming software, you can set up a lot of different functions, like you can keep it level flight, you can keep altitude, you can keep direction, you can of course do acro with safe mode, so if you're doing something stupid you just drop the sticks and it will level out and keep the motor at the running speed so it doesn't fall down. So it's nice for both experienced, because you have a lot of things to play with, to set up and make it do what you want. And it's also nice for beginners because you have all these nice safe features which let it, if you do something stupid you just drop the sticks and it keeps to a safe altitude. And you can also set it, if you flick a switch you can just, it keeps circling. So if you have a problem, it just keeps circling above your head and you have time to get someone other to take over and things like that. So it's a very nice feature. I use this controller in several of my planes, and it's I love this.
Is this expensive equipment?
No, the reason it's starting to get popular is that these boards are very affordable. You can get them from about $20 and upwards. This board is called Omnibus F4 Pro clone, because this is a clone board from China. It's not as good as the real one. It has some small things, like the current sensors is known to not function properly. You cannot read out the current used. It's some cans, many cannot. But if you have a original version, it works very good. It works very good, this to accept this current problem.
How difficult is it to connect and assemble this system together with your radio system?
You have to have some skills, but usually when you are in this hobby, you have the skills of connecting servos to receivers and things like that. So instead of connecting servos to the receiver, you're connecting servos to the board. And very many receivers now, whichever brand you have, you connect this with a serial system with mostly one wire from the receiver to the board.
Like the PPM?
Yeah, PPM, S-Bus, Spectrum has this.
I think Spectrum is PPM, isn't it?
No.
Okay.
Anyway, they have their own system, but Futaba made S-Bus, and FrSky has also used S-Bus. And if you have this popular long-range system called the TBS Crossfire, it also adapts that. And this is open source, so they're very quickly to adapt new technologies. So, and there's a lot of different boards supported. You don't have to buy an Omnibus F4. You can buy very different brands, different generations. This works on pretty old boards, old simple boards, to the newest ones, cheap to expensive ones. So it's pretty easy to set up in a plane. There is some small things, like you have to have a good GPS signal to arm it. Sometimes you take the plane out, you want to arm it, and you want to fly, but it doesn't want to arm. What's wrong? Most likely it's that the GPS haven't have enough time to connect to enough satellites.
Okay, but this GPS system, there are many types out there, and the type that you are using isn't the most expensive one.
No, these are very cheap GPS modules. This is a GPS module without compass. You don't need compass in a plane. The plane moves forward. The system knows that. It doesn't move sideways or backward like a quadcopter. So the system knows that in the direction it moves must be the front of the plane. So you only need a GPS. It knows that when you're moving in this direction, okay, it's pointing in this direction too. So it doesn't need a compass to know where it's pointing. That means that the GPS modules can be made cheaper. So this is a small type, cheap, and when you want to buy components for this system, you search for GPS module for Clean Flight, Beta Flight, Inav, and then when you find this on eBay, Banggood, AliExpress or anything, they usually set up, it's mostly plug and play. You may have to solder wires, maybe it's different connectors, so if you're into this, you need a bit of soldering skills. That's quite important.
So I'm out of this game.
No, everyone can do it. If you, it helps if you're not very shaky on your hands,
yeah.
Because things are very small on this. But pretty much everyone can do it. Just read up on the internet and a little bit. Read some tutorials. It's like when you're doing electronics. You don't run around on a carpet floor first and touch the electronics. You pick up a lot of static. That's for me it's obvious, not for everyone. And also this, you need to have helping hands when you're soldering, things like that. But it's not difficult. It's something everyone can do, and also it's not very expensive. These boards are very cheap. If you want, you can buy an F3 board, which is a older generation, a little bit cheaper. Then it's not that bad if you break it by soldering something you shouldn't solder and overheating things. But usually they are pretty sturdy things. You can do very much wrong without breaking it.
Okay, back to the battery, because
yep.
What we can see here is not a typical battery that you will buy at the store.
No.
You have made this system yourself?
Yeah, these are now pretty common high energy batteries. The reason I use them is because I know this plane is capable of flying low speed with low current draw. I can fly with a 4-cell and keep an amperage of 3 amp, and it's pretty low in flying this big planes. So I can keep a low current, and in battery terminology 3 amp is less than half C, or a half times the battery current draw. It doesn't need very good batteries for doing that. So these batteries have a very low C rating. But for this setup it's okay, because I don't draw a lot of amps. If you have a racing wing, this battery is useless, because you get too much voltage drop when you try to draw a lot of amps. But for a long range or long duration flight, these batteries are perfect. They are the same voltage as a LiPo battery, and each cell is about 3.4 amp. So this setup is 4S and about 6,800 milliamps.
Okay, so it's equal to a 4-cell battery.
Yep. 4-cell battery about 7,000 milliamps.
But will a 4-cell battery give you the same flight time as this homemade pack?
If you have a 4-cell 7,000 milliamps, you will get the same flight time, or maybe a little bit better, because it has a higher C rating, but it's almost twice as heavy.
Yeah.
And that's the reason I have this. It's the lightest, highest energy pack you can make. Almost true. You have newer battery which has slightly better capacity, slightly better C rating, but they are quite more expensive. If you want to do like this, like I did, and use lithium-ion battery, you have to take something into consideration. They drain the voltage lower than LiPos. When you are down to 3 volts, you still have quite amount of battery left. So you have to adjust the speed controller to a very low cutoff voltage, or else you risking that the engine cuts off and you still have a lot of battery left, because it thinks that you have a LiPo battery. And LiPos, you like to cut off about 3.4, 3.5 volt per cell. This you can run down to maybe 2.7 before you cut off. So a little bit technical stuff, but most of you will understand that. And of course since I have a video transmitter, I usually have a camera. This camera is broken, had a few mishaps, but it also have this nice on-screen display, which is giving you a lot of information. For the people who is common to on-screen display, it shows a vector of the horizon, it shows distance, height, flight time, what kind of mode this is in, and it shows a lot of useful information. I don't have a goggle, so I put a screen on my radio when I'm flying with camera. There I can see, and even if the camera blacks out, I still have this information, which is quite valuable. There I can see distance to home and direction to home. If I lose the sight of the plane, and if the camera falls out, I still have a vector showing the home direction, and I just can put the radio in altitude hold mode and steer it home, or put it in return to home. So it's a pretty safe system if you know how to use it. One important thing is this board is connected directly to the battery. It have an internal power source, so you can plug a 4S battery to the board and it converts it to 5 volts. But you need to drive servos and external devices from the ESC. Do not draw it from the board itself, because it cannot support a lot of power. A lot of people is connecting servos to the board and they are flying, and if they give full throttle and do rolls and flips, the servos draws a lot of current and you have a so-called brownout of the controller. It resets itself in mid-flight. That's not good. You completely lose everything. And if you're high enough, it's okay, and if you set up everything good, you can arm it again and fly home. But it needs some work, because usually when this is set up from the beginning, it will only arm in horizontal mode. If it falls down straight down, it will not arm, because it's not a natural starting point So if you want to have this opportunity to arm it in mid-flight in case of anything, you have to go in the software and change some variables. Also, when you adjusting for this auto launch, you have to go in and change some variables. So it's a lot of things to learn, but everybody can do it. As long as you can search on Google, you can do this. It's just to search on like Inav. It's this all the software, a lot of this manuals and information is on GitHub. If you search GitHub Inav, you will find a lot of things you need. So yeah, maybe I covered pretty much the most.
So
Yeah.
it's a little bit different and the video is a bit longer than usual, but I think since we got a lot of questions about the setup and how to do things, it can be great to dive into the problems, or not the problems but the system a bit deeper. And also remember that if you have any question, you can post them in the comment sections below, and we will be, or not me, but Morten will be glad to help you. Morten is a fisherman, so he's not always at home and behind the computer, but I will send him some messages when the questions are popping in, and hopefully we can answer you in good time, and hopefully you will be able to successfully make a plane or a system like this.
We have a very close in the mail a new bigger plane which I plan to set up very similar, not so messy, plan a bit, and I also made homemade camera platform gyro stabilized, so maybe we do a video about that too.
Yeah.
In a fairly short time.
And I'm also going to get the Top RC Hobby, the Super Glider, the one that we had but which was broken. And Morten is going to help me set this up with a flight controller system, because we want to do more aerial shots and not those fast ones that you do with a speed drone or a drone, but we really want to get higher and further. So I told you guys before that I'm not into FPV, but anyway, it would be cool to sort of give the airplane sort of a route that we can add some waypoints and get those aerial shots that you really want. And since I'm very interested in video and photo, I think that will be a good addition.
We have a pretty spectacular weather these days, a crazy lot of snow, and it would be really nice to have a aerial camera platform to take a really nice shots of this weather. And that's what I'm hoping with this plane, that it's sturdy enough, reliable enough to send it out there, do some filming, and hopefully get it back in one piece and can make videos of this. We have usually a lot of wind, and I hope this plane I'm gonna build have power enough to fly in a lot of wind, and with this stabilization system I think it's feasible.
Yeah, absolutely. This video almost becomes like a podcast now. Perhaps there's something we should think about.
It's nice.
A little bit, talk a little bit, or perhaps also get live so that we can answer questions on the air. But we are not going. I have I have strived to be more technical, and finally I have this friend of mine that's really into technical stuff, and that helps me a lot, and it can help you a lot. So even though the video is a bit long, it's informative, and I think you all can learn something. I have learned something, and I guess until next time, if you want to have something reviewed, is there any videos that you want us to make? You can also post that in the comment section. We will try to make make wishes come true.
I'm very technically interested, and especially RC electronically. I do a lot of 3D printing and things like that, so everything technical is in my gate, and with Bengt's flying interest and skills, I think we are fulfilling fulfilling
between, yes. I agree about that, and also the one thing that is cool with Morten, together with the rest of the team, is that he can laugh if he crash. I've been called stupid on YouTube many times because I crash my planes. We don't crash them with purpose. Not always. Sometimes we make planes just to see them crash, or perhaps blowing them up. But anyway, we know how to enjoy the hobby. Our biggest problem now is that this shitty weather. I don't lie to you guys when I say it has been like 4 meters snow now the last weeks. We have outside in the back, we have a porch, and it's like 3.5 meters from the ground, and the snow is now coming over the rails on the porch. So
yeah, we have very good time building planes, so now we hope it's gonna be a nice weather to crashing planes too, and flying, not only crashing.
So with that, you guys, thank you for watching, and thank you for helping me, Morten, with making this video.
Yeah, and as Bengt says, if you have any questions, if you have anything you want us to review, just tell us.
If you want to support the work that we do, you can go into our Patreon page. We are on Facebook and of course also on Instagram, but there with pictures of family and planes. So until next time, see you.
Yeah, bye.
Bye.